And this is an update and an evolution of some work that I presented just about six months ago at the last Perl conference in Las Vegas. And so I'm going to recap a little bit of what I talked about there, and then jump into how that work is proceeding into maybe a more specific direction. Okay. So this talk is called Ontologies for Organizing and Navigating Software Repositories, subtitled A CPAN Ontology. So what does that mean? And here I'm going to start recapping. If you're at if you saw my first talk on some related topics 6 months ago, some of these first slides might look a little familiar. But if you weren't there, then this part is for you, just to kind of get everyone on the same page. And I know that everyone's been like on the edge of their seats waiting to hear more from me, right? So this is all fresh in your minds. So there's this evolution of the World Wide Web, right? And this is Web 1.0, right? A very static HTML page from March of 2000. This is Perl.org. And this is the presentation of information. It is, again, static HTML. There's probably no JavaScript in this page as far as I know. And it's just a human readable display of information. You click a link and it takes you to another marked up document. And so it's purely for human readers. And it's nice, right? I mean, when I 24 years ago probably was on this site and probably thought it was the coolest thing, right? Click a link and get a list of new books on Perl, great, but things evolve, and as people wanted more, right, from the web, they wanted more interaction, they wanted more dynamic applications, being able to read and write. I wanted to be able to submit a form, save it to a database somewhere. Then we started to see more of that interactivity. And that kind of, sort of led to a lot of the web apps that we see today, right? So the idea of a front end for an application being a web page, right? A very complicated JavaScript application many times, right? But still a web-based application. So Web 2.0, we started to get into, more interactivity. Well, great, right? So, but really what this talk is about is this idea of Web 3.0 and how, a lot of the visions for, representing and presenting knowledge, there's a lot of great ideas for doing these things going back, over a quarter century now. But a lot of them have been held back, right? And what does that mean? So when Tim Berners-Lee came out with this idea of Web 3.0, he said, fine, we have these these documents that people can read and they're marked up nice, but it's really for human consumption. How do we get at representing these for greater automation? How do we represent knowledge so that it's more computable in a more machine readable format? On this slide, I have this idea of maybe something else. That's kind of like a little bit of a note to the crypto community, who has wanted to maybe redefine this idea of Web3 to be something a little bit more in their realm, right? And the ideas are not actually mutually exclusive, but it's very different from the original semantic web concept from 25 years ago, right? So I'm going to stick with Web 3.0, meaning the semantic web, and the crypto distributed application stuff. I don't know. I won't even give it a name, and I won't mention it again today. Okay. So what would a Web 3.0 version of Perl.org look like? I had this slide from the talk I gave in June, and I threw it out there as a way of maybe getting people to think about, how would you represent information? But really, this is sort of signaling to, the direction that I want to take this work further. But let's talk about that a little bit, right? So here is the current state of this as of the last Perl conference in the summer. I haven't changed the slide since then. But what does that information mean, right? How might you reason, right? And so that idea of meaning, semantics, and that idea of reasoning are really key to this work, right? So two key concepts. And how can we present this information in a so-called computable format, right? Along with a formatted display, like you don't want to lose the ability for a human to read this. You want to maintain its aesthetics, but as long as providing them underlying semantic information. So there's a few different ways of doing this. RDF is sort of like the lingua franca of the semantic web. It's been around a long time, still heavily in use in a lot of data engineering niches, but maybe not as hasn't taken over the world, right? I think that if you do a lot of data engineering, if you do a lot of knowledge graph work, you're absolutely familiar. And if you're a little bit outside of that world, then you've maybe never heard of it, right? Or maybe you've only heard of it in passing. RDFS and OWL serve to define the ontologies, right? To allow for greater organization of concepts, right? Of greater organization of knowledge to allow for reasoning and inferencing. And I know I'm kind of saying words like reasoning and inferencing kind of quickly, but they really are, there really is a deep meaning to those words, right? And I'll get into that in a little bit, but just really quick, here's maybe like a potential view of what a Web 3.0 semantic representation of the Perl.org website might look like, right? And this borrows from a lot of so-called upper ontologies, right? Schema.org and other Dublin core. They define sort of ready-to-made ontologies that you can use and customize as you want, right? So just a very, quick pass at what that might look like. This might be the RDF representation, right? And visually, this forms a graph. Here's what that graph might look like. Again, still kind of recovering, repeating some of the information from a few months ago. Now, what's the limitation here? The idea is, well, now do that for everything, right? Manually create an RDF representation of anything you want, right? Every item in your warehouse, every application in your Fortune 500 company, right? There might be 10,000, and that's where really the limitation, right, is with the scaling. And so what I talked about to kind of catch us up finally is what I talked about at the last Perl conference was how to automate the construction of semantic knowledge graphs of RDF, right? By defining ontologies and then using LLMs to populate them, right? So that helps resolve the scaling issue. And that talk, which I'm not going to repeat here, feel free to watch it on YouTube or read about it in the Science Perl Journal Volume 1. It goes through this process, right? Goes through the process, and in that case, I used an example of a financial prospectus style document from a ETF, right? Exchange traded fund called OBTC, and I went through the process, right? And in that case, I define an ontology for each property. We construct a natural language question using an LLM, and then with that question, use sort of like a miniature version of retrieval augmented generation in order to populate the graph based on its structure, right? That using the structure of the graph to generate questions from an LLM, get answers, and populate is why that previous talk had a sort of a whimsical title, like, structured based unstructuring of data, right? Because the unstructured source is that plain language text. In that earlier example, a financial document. So unstructured, just plain text. And then the structure is the structure that we give manually to the ontology, but then automatically populating that ontology using an LLM, right? Okay, so now we're kind of caught up. That's kind of like where my work on this was as of, around the 4th of July. So that's nice, right? And I got a lot of some nice comments. And if you were one of the people that made a nice comment, thank you very much. But I think some honest feedback that I gave myself, right, was this is nice, but how can we do this as something generally recognized as useful? Or more simply put, so what, right? So what, we can generate this knowledge graph. Knowledge graphs have been around for a long time. What do we get from this? What value can we do to, what value does this provide, anybody? So one of the original authors of the Web 3.0 article, which was kind of famous at the time, that was appeared in, I believe, Scientific American, Aura Lacilla. He gave a talk at a recent conference just a couple months ago, ASWC 2024. And he went through what he feels is and I'm paraphrasing a bunch, so if you can find his talk, his slides online. So don't take my word for it. So just in the interest of brevity, I'll paraphrase his talk as, this is great. We have a lot of successes with knowledge graphs. They're used all over. He himself is one of the leaders around Amazon's Neptune knowledge graph project, right? And he's like, this is great. We're using it a ton. There's plenty of use cases, and knowledge graphs are strong, solid technology. They're going to be around pretty much forever at this point. So that's a clear win. But what is not a clear win is that when the original semantic web was being envisioned, it was during a period of the last AI winter, right? And so a lot of the ability to use knowledge graphs, concept graphs, for artificial intelligence purposes was lost. It was hidden, right? If you wanted to get money for your knowledge representation project, you kind of left it at that. This is how we represent knowledge for wave your hands, greater automation, greater computability, but you really didn't mention artificial intelligence. And so that kind of kept, at the time, the use of intelligent agents, smarter automation, it kind of kept those concepts a little bit off the table. And they kind of have been neglected. Again, paraphrasing that talk from ISWC 2024. But now's the time, right? Now is, sometimes technologies wait for their moment. They wait for their sort of cultural and technological moment when there's an advance in storage, an advance in compute, an advance in whatever area, social or technical, that has held them back. Now's the time, right? And so that was a very motivating talk, and it really matched my ideas for where this work that I'm interested in doing is headed, right? So going back to the original idea of we're the Perl community, and my earliest examples of how is Perl information represented on the web, right? Perl, Perl.org version 1.0, 2.0, and then maybe like a little bit of a hint at like what maybe a 3.0 might look like. Let's make that more than just like a slide I used as an example 6 months ago. Let's really dive into how, that information can be represented and really help advance not just Perl and its, place in, you know, in society and technology, right? But also, how do we advance this idea of the semantic web, right? And so the Perl community has, as of today, 37 years of knowledge, lore, software. And by software, I mean, different repositories, not just CPAN, but primarily CPAN. Actually, CPAN is not quite 37 years old, right? But altogether, there's 37 years of knowledge going back to, old Usenet posts, right? So there's a lot of my point is that Perl is in and of itself a good source of information to be represented in this way. There's a lot of essentially test data. Perl itself is sort of like the knowledge laboratory. So how do we get started with this? I would say, let's start, or I shouldn't sound so ambiguous. I am starting, or I have started, reusing upper ontologies, right? You saw some of them in that previous slide under schema.org, dublin.core. But there's also an established software ontology which handles versions, features, things like that, which can be used for a good defining upper ontology, define sort of the shape and sort of maybe the higher level structures within the ontology at a sort of finer grain detail. There's things that are very specific to CPAN, to our community. This idea of a CPAN distribution having a bus factor, test coverage, right? These are things that appear and we can add. They're not in the upper ontology, but we can add them, right? And so this combination of, CPAN, representing CPAN, not idiosyncrasies, particularities, things, features specific to CPAN, as well as sort of an upper level ontology, we get a complete ontology, a complete representation of CPAN and all the software in it and all the information, the knowledge, the documentation within it. So let's go back to so what, right? You're hearing me talk, you're hearing me describe this ontology. Well, so what, right? Well, let's get back to the idea of agents, right? So just very simply, what is an agent, right? And I think maybe just very simply, the idea of an agent is just think of a bot, right? Suppose you want a search bot for software, the latest CPAN release. Well, that's pretty easy. In fact, that's already on the front page of CPAN, right? Is sort of like the most recent things. But think about more complex queries, right? Suppose, and actually I just looked at cpan.org, just a little while ago. Some of the top most recently released modules were like MapTube, right? So MapTube is a module that has to do with the London subway system, right? And so suppose I wanted to search for not just the most recent modules, but suppose I wanted any module to do with maps or GIS systems or anything to do with transportation. How would you do that now, right? Like you could scrape CPAN and then you would have to have your own maybe keyword search over familiar terms. It gets very messy very quickly to have that level of intelligence to your search. And that's where an agent comes in, right? An intelligent agent for CPAN would be able to make a simple query against the ontology that would say, hey, give me all the most recent modules that have to do with transportation, right? That's the answer to the so what question. It allows for more intelligent interactions, more not only intelligent interactions, but automated interactions using this idea of agents, right? The idea of agents is a little bit broader than that, but I think a good mental model for the purposes of this talk is just the idea of a bot. How can you build a smart bot which you can interact with, you can give instructions to, and really just any sort of query in which to perform some action, not just sort of point in time interaction, but also this, to completely surveil a system or multiple systems and send alerts, right? So when you have agents that are smartly surveilling the internet, they need to communicate with each other. And so part of this work is my taking on this idea of the conceptual graph interchange format as a way for bots to communicate to each other. CGIF has been around for a long time. It's part of an ISO standard. It was primarily authored by John Sawa, who based a lot of his work on the fundamental 19th century philosophical writings of Charles Sanders Peirce. Peirce had this idea of existential graphs. As Sawa, a 20th and 21st century computer scientist, took those ideas and represented them in what he calls conceptual graphs. But really, it's taking 19th century ideas and putting them into 21st century computable formats, and that's what CGIF is. Here's an example, right? So here's an example for a module, right? Very readable, right? This is CGIF. This is a representation of a certain module. It has these attributes for the author, version, feature. This is a very stripped down, simple example, but this is the idea of this is a plain text message format that can be exchanged between agents, right? Or be given to an agent by a system in order to process things, right? So what's the status of this work? So obviously this is a Perl Community conference, so all this work is happening in Perl. There's very few existing ready-to-use off-the-shelf CGIF generators and parsers. There's a lot of them are buried sort of in older academic work, which is a little bit obscure and hard to find. None of them in Perl, none of them really easy to access. A lot of one-off grad student style projects. So first and foremost, that I've been working on is a Perl-based CGIF generation and parsing work, and that work is ongoing. And also kind of going into a little bit more of the theory on my end of the idea of existential graphs, of Peirce's earlier work, and Sawa's contemporary representation of it. The initial ontology that uses this upper ontology is the shape of it's there, but a lot more further work is required. And then this idea of Perl-based agents starting to interact with this new representation, this new semantic web, this new knowledge graph, I should say. Those are really still in the design stage. They're still really just an idea. But I think that once there's more of an underlying knowledge graph, more of an underlying concept graph, those agents will come into place, and a lot of there's a lot of opportunity for reusability, especially once the message passing work is totally flat ironed out, right? So that's why the CGIF work is first and foremost. So that's kind of it. Hopefully, checking out my watch, I think that was about 20 minutes. So any questions? And if you have questions, let me put up this final slide. If you want to reach out and stay in touch, I'm on Mastodon. I have there's a Discord server. I think a lot of people here are already on it, but if you're not, join in or connect on LinkedIn. So there you go.